Welcome to my presentation of a mock project in the course Stress and Sleep. My name is Jon Klinsson, and I want to talk to you about how we can use our current knowledge of psychophysiological processes as a point of departure for the development of pharmacological interventions for people unresponsive to other treatments. Now, the neuromodulator dopamine is known to be associated with wakefulness and behavioral arousal. This is in contrast to a hormone called melatonin, which is associated with sleepiness and thought to be the cardinal site Geber. That is to say, melatonin is suggested to be the conductor of the timing of sleep and sleep onset, although it's not necessarily its causation. However, researchers do disagree about its exact role. It's nearly perfectly correlated with sleep and sleep onset. Now, interestingly, dopamine inhibits the production and release of melatonin. It thus logically follows that more dopamine that is expressed in the system is associated with less melatonin, which in turn would implicate sleep and sleep latency or sleep onset latency. From this, my project departs, and I hypothesize that increased levels of dopamine at bedtime inhibit the release of dopamine and thus delay sleep onset. Moreover, I also hypothesized that by antagonizing the dopaminergic receptor sites with an inverse agonist, for example, haloperidol, sleep onset latency decreases when compared to a baseline due to a depletion of dopamine in the system, which in turn increases the production and release of melatonin. By studying these associations in the sleep lab, subjecting participants to a full polysomnography to acquire an accurate depiction of their sleep architecture, monitoring levels of dopamine and melatonin before bed and throughout the night, my hope is for this proposal to contribute to the increasing literature on sleep complication. The average person spends 1/3 of their life asleep, but insomnia cripples roughly 30 to 40% of the population each year. Moreover, the proportion of people in the population that can survive on 6 hours of sleep or less, rounded down to the nearest whole number and expressed as a percentage, is 0. Thus, furthering our understanding of how sleep onset may be pharmacologically induced is of paramount importance, given that not everybody responds equally to currently available treatments. The results should be interpreted with a few limitations. For example, that other neurochemicals may interact with dopamine and melatonin, for example, adenosine, and this would be something for future research to map out better. Thank you for your attention.